And we're live again. So we were discussing this problem. Um, Now we'll continue with this problem. I'll explain to you how we are actually going to go about this. Okay, pretty interesting, really interesting actually. Now I'll tell you how to do this. So the first approach actually, right? So the first approach, I'll call this A1. Okay, and this is basically what we will do is you can see now. So we know that a palindrome, as I was saying, that a palindrome basically will consist of three letters, and we know that this letter will be equal, must be same as this letter, right? We do not care what the middle letter is. This can be any letter, right? This can be any letter X. Okay. Now what we are going to do is we're going to iterate through all the letters in the alphabet. That is from A to Z, and then in the string, for example, B B C B A B A, from all the I know all the letters, we will have to traverse all the letters. Reason being, we do not know what are all the characters that are present here, right? So we will go through all the characters, and then and then and this will be just simply 26 operations, right? This will be big O of 26 operations because we're iterating 26 times. That is not a lot. So we will go through this and we will create, and we will actually find the first and the last index. So we will find the first index of, let us say, if I'm talking about letter B, we will find the first index of letter B, which is, let's say, I, the last index of letter B, which is J, and then we will try to find all the characters, all the unique characters that appear between these two letters. Now, why are we taking the first and the last character? Reason being, we want the maximum number of characters in between these two letters. Okay, the maximum characters that can occur in between these two letters. For that, we're taking the first and the last index of this letter. Now, the different characters that are occurring between the two B's, you can see is are A, B, and C. And that is why number of palindromes we will have starting with and ending with B will be 3. Okay. Similarly, we will choose A. When we choose A, we will choose this letter, this index, and this index. And then we will see that there is only one letter between the two A's, and that will be one another palindrome, which will be A, B, and A. So the total makes it 4 palindromes. So that is how we're going to solve this problem. Okay, so the if you look at the time complexity, so the pseudocode basically, if we talk about the pseudocode, we'll first, in order to store the first and the last index, we will create two arrays. Okay, no, we'll not create two arrays. Basically, what they're doing is initially they are, yeah. So we will use hash set, since hash sets do not record duplicates, right? So we can use hash set. We iterate over each index k between I and j, and s and add sk to our hash set between. Okay, and where do we store the first and the last index? Okay, so we will create a hash set again. We will create a hash set which is letters for all the letters in S. So that's what we were iterating from. Okay, all right. We're not going to do this initially. We don't have to do that. Right? We'll use a hash set to store all the characters of S. Okay. Okay, let's write the code. So we'll create a letters, which is a hash set of all the letters in S. Okay. Fine. Okay, wait a second. I need to check. Okay, if you're storing this, where are you storing the first and the last index? Are you not storing? Okay. Okay. All right. So we first create an unordered hash set. We say for character C, we will insert all the letters, all the characters that are present in the string. For each letter in the letters, we'll say I is -1, j is 0. Okay. For it is a k is 0, k is less than s dot size. If the value of sk is letter, we'll set the value of I is equal to k. Otherwise, we'll just keep setting the value of j is equal to k. And then we'll create an unordered set between. For every character in between, we will insert it in the set, and then we'll just simply say answer plus is equal to between dot size. Quite simple, quite nice, right? So, right. Okay. Hash set. Okay. Right. Unordered set letters for right, charge C is say letters dot insert C. For each letter in letters. For each letter in letters, we'll say this is the initial position. This is the final position. Okay, I need to have this as k. Since I is already declared, I need to use k. This is equal to letter. We'll set the value of I is equal to k. Otherwise, we'll just simply set the value of j is equal to k. We'll create an unordered set again. Between for integer I plus 1 k less than j plus 1 k plus plus. Just have to insert the values, right? Obviously, and we also need to check if the value of I is equal to -1. Otherwise, we cannot even make this interesting. The last value that we have is k, so we need to go till j minus 1. Let's simply say Might have made a mistake somewhere. I don't know. I'm not feeling well. I feel I don't know what is happening here. Okay. Right. So the first thing we have is unordered set unordered set letters. We create a hash set initially. We insert all the letters inside the hash set letters. Okay. Letters dot insert. So we say letters dot insert the character for every letter in for every that is every character in S string S. Then we have integer answer is 0 for character. Every letter in letters, we say integerize 1 minus 1, which is the initial position. So this is the starting index of letter, and this is the final, or you can say ending last, I should say, index of letter. We say integer case 0 case less than s dot length. If s of case letter integer I is minus 1, if the value of s of k is letter and if the value of I is minus 1, then the value of I is equal to k. Otherwise, we just simply set the value of, otherwise, where every time we're just going to set the value of j is equal to k. But this happens only if the value of sk is letter. Now, this is what I was doing wrong. So we only set the value of j as k if the value of s of k is equal to the letter, right? Then we simply create an unordered. Again, we create a hash set between. We insert all the letters in between, and then we add the size of the set to the answer. This will work in big O of n. This actually works in big O of n right away. Big O of n and big O of time complexity. Space complexity cannot be big O of 1, I believe. Can the space complexity be big O of 1? What is the space complexity? What should it be? They cannot grow beyond a size of 26. Okay, so the time complexity is constant. So it is big O of 1. Nice. Now, another approach is to basically, now this is what I was actually having in my mind. That is what we can do is instead of doing this, instead of having this set, okay, instead of creating this set and every time every time calculating the value of this, uh, every time calculating the value of the number of letters that are in between, what we can do is rather create an array, right? So what we are going to do is, I'll tell you what. So we're going to create an array that is going to be an array first and an array last. Now this first array, which will be of size 26, okay, and a last array which will also be a size of 26, they will both store the first and the last indices respectively of all the letters from A to Z. Once I have, for example, for A, let's say the starting index is 1 and the ending index is, let's say, 10. The number of letters in between is simply going to be the difference of these two letters, right? So we are left with, so we are able to avoid one whole operation, as you can see, right? Okay, so right, let's delete this, right? So we're not going to use a set anymore, unordered set. We're going to say we're going to actually create a vector, right? So we're going to create a vector integer, and then we're going to call it first, and size will be 26. We'll create another one, which is last, which is also going to be 26. Okay. We need to initialize it with -1. I'll have to initialize it with -1, so I'll say like this, where -1 and this will be 0, right? For okay, so we'll say for char ch is equal to a, ch is less than equal to z, ch plus plus. If the value of is the value of uh, okay, integer I is equal to 1 is less than 27, I'll say. I plus plus. If the value of first of I, which is 1, is equal to minus 1, which means the value has not yet been set. So um both of them are to be initialized with minus 1. I'm thinking of something. Yeah, I don't know what I'm doing. I don't know why I'm doing this. We have to basically, I don't know what was going in my mind. So for integer I0, I is less than s dot size and I plus plus, what we're going to do is we're going to say the current value is equal to si minus a if the first of current. Okay, so if the first of current. So what we're calculating is si minus a will actually give me, so si is basically, let's say, a. So this is actually going to give me the number of that letter. So for example, if I have Z, it will give me 26. B minus A will give me 1. C minus A will give me 3. C minus A will give me 3, and so on. So if the value of first of current is equal to minus 1, then we're going to say that the value of first of current should be equal to I. Okay. Otherwise, um, we're just simply setting the value of last of current, whatever current is. Okay, we're going to set it to I, which is S of I minus A. It is, if it is 3, 5, whatever, right? If first of current is equal to minus 1, we set the value of first of current is I. I was thinking about some, and if it is A, it will actually be, so this is important. How do you insert the values? This is actually, this might look simple. This is actually important. Okay, this is actually important. How do you insert the value? So using integer current is equal to S of I minus of A, right? So important line. Okay, integer current is equal to S of I minus A. Using this, you insert the values. Then you say again. Now after this, you just do the same process. The only difference will be you have integer I is minus 1. You don't need to do this now because now we already have the first and the last index. We don't need to do this. We can simply save the value of first of. We can now actually just iterate through the all the letters. Now we're going to iterate through all the letters actually. So it is I0, I is less than 26, and I plus plus. Okay, so if the value of first of I, if the value of first of I is equal to minus 1, it means that it is not present in this, in the, not present in the, it means that if the value of first of I is minus 1, it means it is not present in the string. So we're just going to continue. Right, we're going to continue. Otherwise, we're going to create an unordered set between. Now we don't need to perform this because we don't need to perform this since we already have the, we don't need to perform this since we already have the first and the last. I don't know why I deleted that. Okay, so we'll remove this. We will still have a um, right. So we will still have an unordered set between, and for that, what we're going to say is the number of characters in between will be simply first of I. So we'll start. Firstly, we'll start from this I, and j will be less than last of I, which is the last index, and j plus plus, and we're going to say between dot insert of s of j. and we'll say answer plus is equal to between dot size. Okay, so now what we saved was the time where we saved time was actually when we were computing this whole thing. So when we were actually computing the first and the last index for we were computing the first and the last index by iterating again and again. Wait, not again and again. So we were actually calculating the first and last index by iterating through the array, which was in big O of n. So now now this, even though this is a big O of n operation and it might seem small, but it is actually not, okay, because big O of n, imagine the value of n being 10 raised to the power 5. So it will take up a lot of time just to arrange the first and the last indices. Okay, so that's why we save time there, and we actually save time there, and we don't have to, right, we don't have to actually go through the string just to mark the indices. And then for as for the set, we need to again do that. Obviously there's no set here as well, so that is also there. We don't have to iterate through the set, right? So we don't have to iterate through the set, and we are just left with iterating through the um, 26. So now we're not iterating through the letters, all the letters, but just through 26 operations. Okay, the letters, let's say there are a lot of letters, 10 to the power 5, that would be big, but we're not just having, we just have 26 operations instead of big O of 2n or something like that. We just have single big O of an operation now. This time we just have a single big O of an operation. Okay, cool, really cool. Submit this, and cool. Okay, big O of an operation, simply big O of it. All right, that was today's lead code question. Okay, all right. Approach to, okay. Count palindromic subsequences. What is this question? Let's see. Mm, okay. Heap stacks and queues, very stacks and queues. Today we are going to do a very important part of stacks and queues. Okay, it's going to be fun. Mm, why is it opening? And I just want to open this. No, this limited storage. Oh my god. All right. I think when I get into Microsoft, I'll get these for free. I should be right. If I get into Microsoft, I should be getting these for free. Anyways, let's add stacks and queues. Let's add stacks and queues part two. I'll get a new page today. Stacks and queue problems. Monotonic stack. So we'll name that only. Monotonic stack slash QUE. Problems. Okay. Want this to be black. What should I choose? Gray? Should I choose gray, guys? Dark gray. I'm gonna go with black. That's the good. That looks good. Okay, let's do this first, then we'll start with the stack and queue problems. Okay. This is 2484. Okay. Okay. The question says given a string of digits S, return the number of palindromic subsequences of S having length 5. Since the answer may be very large, return it modulo 10 raised to the power 9 plus 7. String is a palindromic blah blah blah, or subsequences of blah blah blah. My eyes are paining. I don't know. Okay. Right, the question is given a string of digits S, return the number of palindromic subsequences of S having length 5. Since the answer may be very large, return it modulo 10 raised to the power 9 plus 7. For example, 103301, there are 6 possible subsequences of length 5. 10330, 10331, 10301. Oh my god. Oh my god. This is even more difficult. Oh my god. I need to think of a way to do this. Let's see if we can figure out something. All right. Five. Hmm. Number of palindromic subsequences of S having length 5. Does this involve DP? Oh my god. I hope it does not involve DP. Does it actually involve recursion? Dynamic programming? I think maybe it might because it's a long problem. Hmm, okay, let's think 103,301. If I try to iterate 103, if I try to iterate over 1, if I try to iterate. So basically, if I iterate over 103,301, 10330 and 103,301. 1, 2. Mm, string of digits is. Okay, I think this might have something to do with the sum. How? What if we try to calculate the sum of numbers? Because in a palindrome, the sum must be same. Like the sum must be twice. Like if you try to think about, let's say 103,330, you have 10330 is not a palindrome. Palindrome is 10301. So you have the sum as 4, which is sum as no, okay, it's not even. I thought the sum must be even. It's not. 1310301. What am I kidding? Okay, what else? What is left? DP. I don't think DP is going to be used over there. No, no DP is used. Um. See you. Okay, 103301. Okay. 10330 and then 1. Okay. 103301. Let's try to find the subsequences first. What are the different subsequences possible? One, obviously 1033 and then 0. 1033 and then 0. Length 5, 1, 2, 3, 4, 5. So 10330. You could have 103 and then 01. You could have 103. Now I'll have to take 10301. I've already taken. Okay, now I'll have to start with this 3. No, we cannot start with that 3. 10330, 10331. Right. Okay, right. 10331 should have been already there. 10301. 10301 again. 13301. Yeah, right. I can miss that. 13301. And then, okay, 0 is also counted. 03301. 0 3 3 0 and then 1 3 3. So 0 3. Right. So 0 3. Right. So 0. Right. Right. So 0 3. Right. So 0 3 3 0. Right. So 0. Right. So 0 3 3 0 and then 1 3 3 0 and then 1. These are the subsequences possible. Only palindrome among this is 10301. Right. Okay, multiple have to be counted. That's another problem, that duplicates are also counted. Great. Is that a problem or that is nice? I don't know. I mean, cannot be a problem. I did. Wouldn't have been a problem. I could have stored it in sets. That's all. 1033. So, which means if you look at this palindrome, right? 10301. One zero three zero one. Okay, again, let's break this down. Let's break this similar to how we broke the previous problem. How do you figure out that 10301 is a subsequence? How do you know it is a subsequence? Because this matches this matches this, right? It's a string, right? We can just simply say reverse of this is equal to reverse of that as well, right? Hmm. So Okay, let's ask. Okay, let's see the hint. There are 100 possibilities for the first two characters of the palindrome. What? There are 100 possibilities for the first two characters of the palindrome. First two characters of the palindrome. One, two, three, four, and 5. You're saying first two characters have 100 possibilities. How is that possible? And why is that possible? Because, okay, so they're, oh, okay. 0, 0, 0, 1, 0, 2, and so on. This will go on, right? So this will be, I think, 100 possibilities. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and so on. Zun, right? 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. Then you'll have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. So like this, you will have 100 such possibilities for the first two characters. I think it is enough to say that the last two characters will also have 100 possibilities, right? This is, so it is enough to say that the last two characters also have 100 possibilities. Now the middle character, again, again you have to realize that the middle character can be middle number, or the middle digit can be any digit, and it does not matter. I just forgot that it is length 5. If it is a variable length, you cannot do it. Simply, it's not possible to do it with a variable length. Also, I don't think it's possible to do it with an even length. But you have an odd length, and the middle character can be anything you choose. Okay, and that is why, okay, it can be done with an even character, even it can actually be done with an even number of it can actually be done with an even length, because then you will take the first three characters, but then there will be 1000 possibilities for the first three indices. There will be 1000 characters, 1000 possibilities. For the last three, there will again be 1000 possibilities, which is a lot. Now what we can do is look at the second hint, right? Okay, so the second hint says iterate over all the characters, letting the current character at the center. Iterate over all the characters, letting the current character be the center of the palindrome. Iterate over all characters, okay, letting the current character be center of the palindrome. Letting the current character be the center of the palindrome. Okay, let's do that. Iterate over this. So it's saying iterate over all the characters 1, 0, 3, 3, 0, 1, and the current character is the letting the current character be the middle of the palindrome, right? Center of the letting the current character be the center of the palindrome. Let's just test part 4 again. So which means, for example, we have 1, 0, 3, 3, 0, 1. So when we are traversing this, so 1 will be the center, 1 will be the 0 will be the center, which is not possible because we want a subsequent. So we can, so we will have to actually, we know we will have to start with 3. We know we will have to start with 3. I mean, the middle, if you want, I mean, the thing is, I'm saying the middle is always going to be from this, right? The middle is always going to be from this. So we choose 3, let's say, as the middle. We can have, we choose 3 as the middle. We can have 1, 0, 1, 0, 3, or we can have 0 and then 3. Where does this lead us? Where does this lead us to? I think I'm spending a lot of time on these problems. But what I don't want to do is just look at the solution, because that just ruins it all. It just ruins the intuition and the logic building. It just ruins that. But I don't think I'm left with any other choice. I don't think I'm left with any other choice now. Let's read the hint again. There are 100 possibilities for the first two characters of the palindrome. Iterate over all characters, letting the current character be the center of the iterate over all characters. Wait, why does this only have 518 likes? Why does this have only 518 likes? Solutions are pretty also. Solutions are also pretty less. It's a DP problem. It is a DP problem. No wonder I'm not able to think about it. It's a DP problem. Yeah, I was talking about longest increasing subsequence. The DP solution is beautiful. Okay, I'll do this question later on when I'm doing DP. We'll just leave it for now. Just copy this. I'll paste this somewhere. I'll paste this on a blank page. Um, let's just paste it here for now. I'll get this. What is the longest increasing subsequence of it? I've done this one. (2022). Oh my god. Ah, what was I doing? Okay, it's a string problem, right? If I'm not wrong, it's a string problem. Palindromic subsequence in given string. Longest increasing subsequence. Longest. I think it's a DP problem. Subsequences. Yep. How could I forget DP and subsequences? DP on strings. Longest common substring. Longest palindromic subsequence. DP28. Longest palindromic subsequence. Longest palindromic subsequence. These are all DP problems. Right. Okay. Subsequences are basically DP problems. Okay, fine. Cool. We'll do that when we come to DP. Right? Graphs and DP will take some time, like maybe next week. Okay, now let's move back to this, which is next grid element. So it's a simple problem, I think. I hope to do it quickly. Next grid element 2, next smaller element number of NGEs to the high trapping rainwater sub of subarray asteroid collision subsurvey. I want to do all the problems. I want to do all the problems, and these are also important because these are actually important. LRU cache. I've heard of this like in an interview. Sliding me to maximum stock span LFE cache. Right. Okay. We'll do all these. Hopefully, I can do these before 2 o'clock so that then after 2 o'clock lunch and then okay, cool. Right. So let's do this problem after I take up. Next trader element. Let's do this. Okay, I'll do this in a way because I need to solve 12. How many problems are these? These are 11 problems, right? If I take half an hour for 11 problems, I'll not be able to finish them. So I'll set a timer. I'll try the problem for 5 minutes. If I'm able to come up with something, I'll try to do it for the next 5 minutes. If I don't do it, I'll start with the solution after 10 minutes. If I'm not able to do anything for 5 minutes, I'll start with the solution. That's how I'm going to. Right. Okay. Okay. All right. Right. So the question says the next greater element of some element, the next greater element of some element x is in an array is the first greater element that is to the right of x in the same array. You're given two distinct zero-index integer arrays, nums1 and nums2, where nums1 is a subset of nums2. For each I 0 to nums1 dot length, find the index j such that nums1 of I is nums2 of j and determine the next greater element of nums2 of j in nums2. If there's no next greater element, answer for the query is -1. Return an array answer of length such that answer I is the next greater element as described above. For example, we have nums1 is equal to 412, nums2 is equal to 1342. So 412. You said nums1 is a subset of nums2. Okay. For each I, find the index j such that nums1 I is nums2j. So 4 is underlined in nums2 is equal to there's no next greater element, so the answer is -1. Okay, so for each I, basically for each for each element, you can say in nums1, supposedly, for example, the first one is 4. You have to find 4 in nums2, and then you have to find the next greater element for 4, which is none because there is no greater element. Then you have 1. The next greater element of 1 is 3. Then you have 2. The next greater element of 2 is also -1 because there is no one. So that is how it is actually working. Okay. All right. Simple question, not that difficult. Quickly, if I try to think of a solution, I think I can come up with something. 4121342, right? So 412. So this is the first one, which is 496. 496. This is 412 and 1342. So I'll write N1 as 412 and the value of N2 as 1342. 1, 3, 4, and 2, right? So N1 is 412 and N2 is 1342, right? 412, right? Now, so we have to find first look at 4 and then find where is 4 in this array. When we find 4, we have to check if there is any other element that is created to it. Now, this is a stack problem. Okay, I'm going to utilize that knowledge that it is a stack problem. I have to solve it using a stack or a queue, probably not a stack, but a queue maybe, right? So if I have a stack and I insert the element, these are my queries, right? These are my queries 4, 1, 2. Okay. 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 4, 1, 2, 1, 3, 4, 2. If I insert 1, 3, 4, 2 into a stack, if I insert 1, 3, 4, 2 into a stack. Oh, stack, right. Okay. I was just checking. Right. Hmm. Stack. Okay. Stack, 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 stack. Okay, let me find a brute force solution. What is the brute force? Let's start. I just forget every time. Let's start with the brute force solution. For 4, I need to find the next greater element. I mean, it's very simple. I can just iterate through this, and that is the brute force solution. So this is the brute force solution. I can, for every num in n1, let's say we get 4. For 4, I'm going to iterate through the n2. Every time, for each query, I'm going to iterate through this array and find whatever the next element to the number is, which is greater to it. Okay, if no element is greater next to the right of the current element, then I'll return -1. So that will take actually big O of n2. That will the brute force time complexity will be big O of big O of n1 times n2, right? So this will be big O of n1 times n2, which is big O of order of big O of n squared. Okay, which is not a good solution. Okay, which is not a good solution. So that is why what we can do is we can actually store um okay, we can what we can do is we can store something, and if there's an element present we can okay okay store 4 into the stack. Okay, this is difficult to think. Hmm. Okay. Right. Okay. Mm, I feel dumb for not knowing easy problem. I mean, it's an easy problem. Come on, dude. Come on, man. N1 times N2, big of N squared. Okay, but what about big O of? Okay. Maybe there's not a single stack. Maybe we can create 2 stacks. Okay. Let me think of it like this. How can I actually utilize a data structure where I'm able to pop the elements one at a time? So let's say if I insert 4, 1, 2, it's going to be a problem. Let's say I insert 1, 3, 4, and 2 into a stack. This is like this. Stack is going to be like this, right? And I'm going to say that the value, since big O of the stack works in big O of 1 operation, obviously, insertion, deletion, everything works in big O of 1. So I'll say 1, 2, 3, 4 is there. And the current element is 4. Okay. What I'll do is I'll keep popping off. Now current element is 4. The top of the stack is 2, which is less than 4, which is, I mean, sorry, top of stack is 2, which is less than 4. So we'll not store 2. Okay, we'll pop it out. This is popped out. Then we have 4, which is equal to 4. And since, and already my answer I'll set to -1, which means I do not have an answer. And if this stays true, it means there is no answer. So basically we will return -1. But the problem is I need the stack again. The problem is I need the stack again. So maybe I can just use the stack inside this. Okay, let's look at it like this. So, so for integer I is equal to 0, I is less than, or I can simply say for auto nums 1, I'll create a stack. This will take big O of n operation. Every time I'll have a big O of n operation. That will become big O of n squared. I'll have to iterate. That iteration is big O of 1. Probably this is a wrong approach. If I don't do that, but if I don't do that, problem is if I don't pop this out, I mean, how do I know that? Okay, okay, what do I do? I mean, this is probably a wrong approach. I don't see the time complexity getting reduced. Stack definitely has to be used over here on N2 because there's no use using these are queries. There is no use of using stack on queries. Okay, this is the main part 1342 on which I have to use the stack, and if that is true, I should be able to do this. First, order nums one stack int. Um. Okay. Mm, okay, I'll just write this code, but obviously it's not going to work. I don't want to do something which is not good. It is definitely, obviously, if I'm going to fill the stack all over again, if I'm going to create a stack every time for every query, if I create a stack, that will be big of n squared only. So it does not matter if I'm using a stack or not. It's probably useless. It's useless creating a stack, instead of creating a stack because I'm just increasing my workload because in a single iteration, if I'm doing an iteration, I can just simply check when there is an element present, if there is an element present greater than the current element, instead of creating a stack and then popping out, then I'm actually doing more operations than required with the same time complexity, right? Which I don't want. So it's just useless. It's just useless. If I create a stack already, if I have a stack already present 1 3 4 2, but then I pop this to, maybe I can just push the two back. Maybe I can just push the two back. What if I pop? Okay, you're saying push the two back. What if I pop 2 4 3? What if I pop all the elements? What if I pop 2 4 and 3? All the elements but one, right? What if I pop all the elements except for one? What if I pop all the elements x? What if I pop all the elements except for one? What do you do then? Do you then still say that insert all the elements back into the stack? Okay, I give up on this particular problem. I cannot do this. I need to see what needs to be done. Okay, it's an 18-minute video. I'm wondering. Okay, probably not really long videos. Okay, hopefully I can just quickly finish them. Fine. I don't know if YouTube can put a strike on me because I'm displaying somebody else's video. I'll just remove myself from this page. Just removed. So the question is quite simple. I've understood it, and I'll tell you guys what we're doing. Right. So this is our. Okay. I'll just quickly tell you guys what we're doing. Where is this? Right. So let's say this is ours. This is my stack. Okay. What we're going to do is we're going to iterate from the back of the array. Okay. For example, for this two right here, we will say the stack is empty, and this will be our answer array. We're going to create an answer array. So we're going to create an answer array of the same size. Okay, 1, 2, 3, 4, 1, 2, 1, 2, 3, and then 4. Right now, 2 is there. We'll iterate from the back of this nums2 array, and the first element is 2. For this 2, the stack is empty. We're going to so we're going to set the value of answer of n minus 1 as -1, and we're going to push 2 to this stack. Next, we're going to get to 4. Is the value 4 greater than 2? Since the value 4 is greater than 2, it means that this does not have any greater element. So we're going to again set this value to -1. Okay. We will basically remove this element 2. We will pop this element out. Okay. And since now the stack is empty, we're going to set the value of set the value to -1 here as well. Now we're going to get to 3. And we're going to push 4. Remember, okay, we pop the element 2 and then we push 4. The top of the stack is 4 and this element is 3. Since 3 is less than 4, we're going to set the value to 4 here, and we're going to push 3. Since the value of the top of the stack is 3, which is greater than 1, again we'll set the value of 3 here, and this will push 1. Right, so this works like this. So we have the answer array will be 3, 4, -1, -1, and this is not the answer array, because in this case we have the query. Since in this case we have query, so I can say q. Okay, and what I'll say is we need 4. For 4, basically 4 is present at this index, so we'll just return -1. 1 is present at this index, which is basically 3, and 2 is present at this index, which is -1 again. So 1, -1, 3, and so -1, 3, -1 is actually the so -1, 3, -1 is actually the answer, right? Okay, so let's do this. We'll say this is not the answer array. I'll actually call it something else. I'll call it any other array, right? Let's call it q. Okay, let's call it q. Not q. Okay, q is queries. Let's call it c. D. I don't know what to call it. Let's call it d. The size will be same as n, and we're going to create a stack. Okay, so we're going to create a stack, and we're going to create a stack st or s, whatever. We're going to say for integer I is equal to, we're going to iterate from the back, so it will be n minus 1. I is greater than or equal to 0. I minus minus, and we are iterating nums2, remember. So we're going to say if the value of so if the stack is empty, right? If the stack is empty, I mean there's no other option than to set the value of nums2 of I, not nums2. Okay, set the value of d of I as equal to -1. Otherwise, we're going to say if the stack is not empty, and if the value of the top of the stack is greater than the current element, which is nums2 of I, okay, the value of nums2 of I, then we will set the value to be we will set the value to be right. We'll set the value to be, if the top is greater, we'll set the value of d of I as equal to st dot top. Otherwise, we will have to, while the value of st dot top is greater than, so while the value of st dot top is less than nums2 of I, let's say, right? So the value is, let's say, less than nums2 of I, we will have to pop the stack. So for example, in case right, for example, as I'm saying that we have, let's say, In the stack, we have 2 and the value 4 is greater. So I'm going to pop 2. I'm going to keep popping until I get this value, right? And if the stack becomes empty, in case the stack becomes empty, it just simply means that my value is going to be -1, right? So I'm going to say, well, the stack.top is less than nums2i. Stack.top is less than nums2 of I. I'm going to keep popping. So st.pop. And then I'm going to check if the value of st.top becomes, I mean, if the value of stack is empty, then we'll set the value of d of I as -1. Otherwise, I'm going to set the value of, otherwise I'm going to set the value of d of I as, okay, instead of just checking and just setting the value -1, I can then simply say initially all the values are -1. That's better, I think. That is actually better. So, it simply means if I'm not setting any values, it's just simply -1, right? Stack is empty, di is -1. So I can simply say if the stack is not empty, if the stack is not empty, right, if the stack is not empty, then I'm going to perform this operation. Okay. Again, similarly here, if the stack is not empty, I'm going to set the value of d of I to st.top. So wait a minute, let me just check this. So basically, so we have 2 over here. We push 2 into the stack. So we say if the value of stack is not empty, okay, since the value of stack is empty, nothing happens. But okay, I need to push, still need to push that value, right? So I'm going to say st dot push nums 2 of I. Okay, so 2 is pushed. Then we come to 4. The value for 2 will remain -1 only. For 4, we will say st is not empty. So if the value of st dot top is greater, which it is not, since the value is less, we'll say while st dot top is less than nums2 of I, since the value is 2, we're going to pop if the value of st dot, so we're going to pop if the value is not empty. If the stack is not empty, we're going to set di as st dot top. Otherwise, just we're going to simply, we're simply going to push the value 4. We pop and we push the value 4. Okay. Then we move on to 3. The stack is not empty. Stack dot top is 4, which is greater than 3. So we set the value di as st dot top again, which is 3, which is 4. And then we push 3. Okay. Then we come to 1. Again, this will happen. Okay. All right. So this is happening, right? Now we have this. Now we have this now we have this. Okay. What we need to do now is I want to okay, I wanted the value. Okay, what if I just simply, instead of doing this, what if I did a better thing, something better, because the problem is here that we want this 412, right? So instead of d of I just simply set the value, but okay, right? But these are 1, 2, 3, 4. Okay, the elements are not going to be 1, 2, 3, and 4 probably. Are they going to be 1, 2, 3, and 4? Nums 1 dot length is 1, 2, 3, 4. But what are the nums? Right, so you see nums1, nums can be 10 is to the power 4, 0 to 10 is to the power 4. You're not going to have an array of 10 is to the power 4 size, are you? So you're not going to have an array of 1 to 10, 0 to 10 is to the power 4. So let's say if this was 1000, 3000, 2000, 4000, you wouldn't be writing, having an array of that size. So you will have to create this. And then since you're asked the value of 4, since you're asked the next iter element of 4, what you will have to do to return this value is just simply, don't tell me I'll have to iterate it. Do I have to? I mean, come on, man. Do I have to iterate over this and find where is 4 and then return this? Do I have to do that? Do I need to do that now? Okay, no, I don't. Okay. Let's try to. Okay, I'm not returning anything right now. I need to return a vector. I'll return d for now, and it's not going to work. I just want to see what I get right. Should be at least according to my. It should be at least what it should be is nums2. Right, so it should be this 3 4 minus 1 minus 1 misaligned address vector int dn minus 1 stack integer st I is n minus 1 I is greater than equal to 0 I minus minus. um okay okay st dot push comes to I. What is going on? What is going on? Where is the problem? Which line is the problem? Cat 16. Misaligned address for type int which requires 4-byte alignment. Pointer points here. Okay. Stack int st. St dot push. Um, I don't think so. It's because I'm returning a different length array. I don't think that's the answer. I mean, I don't think that's the reason. I could try. Well, minus 1, 3, and then minus 1. What is this, man? Line 173? Are you kidding me, man? 173 is where 173 is where. Okay. Vector integer d n comma minus 1. This is going out of hands. 29 minutes. Come on, man. Okay. Got no option. Check what is the problem. I don't understand. Okay. First, I need to create a map to store the values. That I know. App intended next. I've got it NGE. Stack it to ST. What is the problem? No, why am I? Don't tell me that. Okay, just okay. I think I might be having a stack overflow or underflow error. Okay. If the stack is not empty, so if the stack is not empty, while the stack is not empty, you have to st dot stack is not empty. I don't know what is the problem with this. If the stack is not empty, if the stack dot top is greater than if the stack is not empty, and if the value of stack dot top is greater than nums2 of I, so 3 and 4, right, something like that, then the value of di is equal to st dot top, right? Else, while st dot top is less than nums2 of I, st dot pop, if st is not empty, di is st dot top, while st dot top is less than nums2 of I st dot pop. At least it should be working for this example. No, that's what I'm saying. 2 is inserted, so 2 is there. Initially, we put this value as -1. 2 is inserted, right? 2 is inserted. st dot push nums2, st dot push nums2 of I. The stack is not empty. The stack is empty, then push nums2 of I, right? And then we have 4. We say 4 is, we say that the stack is not empty. So we basically check if the value of st dot top, which is 4, is greater than 2 nums2 of I, which is st dot top, which is 2, is greater than st dot top? No. So while the st dot top is less than nums2 of I, while st dot top is less than, wait a minute, st dot top, while st dot top is less than nums2 of I, exactly. So 4 is greater than 2, pop 2. So st dot pop 2 is popped. Okay, I have to, okay. Oh my god, I have to write st dot empty. How can I pop if there is, whenever I'm performing a pop operation or something, I have to check whether it is empty or not. I need to check, I should check whether it is empty or not. I'll get a wrong answer, but at least I see that I'm getting -1, 3 and -1. My what is my nums output? -1, 3 and -1. Maybe I'm not returning D again. Okay, yeah, I need to return D. I want to see my, what should be returned is 3, 4, -1, -1. So I get 3, 4, -1, -1. Exactly. Okay, nice, cool. Okay, remember to just check these values. Now I can actually use a map and store the values there so that I can return whatever is unordered map int comma int mp. And what I'll do is for integer i's n-1 i's greater than equal to 0 minus. I'll say, okay, I need to, what do I need to do? I'll not say di is equal to st dot top, but rather I'll say the value of mp of for that particular value right? MP of value of d of I means for this particular index, right? I'm actually calculating for this index, but rather than that, we should be calculating for nums1 of I, nums2 of I, because it is nums2 of I, obviously. This is equal to st dot top. Okay. Again, instead of di is equal to st dot top, I'm going to say mp of nums2 of I is equal to st dot top. All right. And then in the end, I'm going to iterate through my map. So for auto int mp, I'm going to say I need to create an answer array probably. Vector integer answer for auto int mp or map mp. So for auto int mp, I'm going to say not for auto int mp. I need to iterate for auto nums1. Okay, the value of answer dot push back. So for auto, right, so for auto nums1, for auto nums1 answer dot push back mp of num return answer. All right, let's see. Zero zero. Okay, because I'm not inserting -1 otherwise. I need to insert -1 otherwise if the stack is not empty. If the stack is empty, else I need to say mp of nums2 of I is equal to -1. Else mp of nums2 of I is equal to -1. Nice. Okay. Right. Took me a lot of time to do this. I don't actually use the problem. Okay, reason why I was not able to remember unordered map, because I actually just use simply map. But it's better to use an ordered map if you don't require actually sorting, because a map will take an logarithmic time, n times logarithmic time, and an unordered map will take less time. So that's the thing, right? Okay. Anyways, right. The problem is also make sure whenever you're writing the operations like top or pop, make sure that you are actually right. You're actually checking right conditions. Whenever you perform okay, fine. Uh, I can click on this, but wait, before I click on that, I want to look at the what I want to look at. Stop the screen. Let's look at the other. And ST is not empty. Right, I need to write cleaner code. I need to start with while the stack is not empty and the stack dot top is less than equal to array of I. Right, so I need to write a cleaner code. Instead of writing, this is very cumbersome actually. If stack is not empty, then if the stack is top, then I'm checking this condition, then I'm doing else. So I'm doing a lot of else, which is not really good, right? Instead of whole thing, I can actually do a lot better. I can do a lot better. And how is that? Basically, we'll start with. So we'll start with the initial condition while the stack is not empty. Okay, and the value of stack dot top is less than the nums2 of I want to make sure that I pop these values. Okay. Then we will actually check if the stack is empty. We'll check if the stack is empty. Then we'll just simply say that the value of MP of nums2 of I is equal to -1, else nums else. I don't even need to create these. Just keep it simple, no? Keep it simple. Just keep it simple. Right? If so if if the stack is empty, then MP of nums2 I is -1. If the stack is not empty, else MP of nums2 of I is simply equal to st dot top. Okay. And then we have to push the value of nums2 of I. As simple as that. Just 1, 2, 3, 4, just 5 lines of code. Not even 5, 1, 2, 3, 4, 5 lines of code. And this was, on the other hand, 1, 2. I'm checking. So first I'm checking if the stack is empty. I'm checking if the stack dot top is greater than nums2 of I. Then I'm saying st dot top. Otherwise, I'm saying while st is not empty and top, then this. If the stack is not empty, then set this. Then set this. Oh my god, this is so much repetition. Just remember, if you have a while loop inside your if or else, there's something wrong going on. Just I think the while loop should not be necessarily inside your if else loop. So I'm checking this if the stack is not empty, pop. Then I'm checking. So this condition where I'm checking while, then while the condition inside the else can be moved outside actually, and then I can pop and then I can check whether simply if the stack dot top is greater than nums2 I, MP of nums2 I stack dot top. Simple as that, right? Stack is not empty. So that is as simple as that. No need to write so much shitty code, right? Okay. Okay, so let's run this again. 5 lines of code, simply 5 lines of code. Come on, man. Let's go. Okay. Right. Just click on this and I'll say Okay, let's move on to the next question. Wait a minute. Let me tell. The time complexity for this code, because we are having a while loop, we have a stack. I mean, definitely we're iterating, so it is going to be big O of n. For the for loop, we're iterating the whole nums to array, so it is going to be big O of n2. And then inside we're saying while, so it can be big O of n1 plus that big O of n2 plus n2. I think big O of n2, but inside that's not, that is popping, that happens in big O of 1 operation. Big O of n, man, big O of n is the time complexity. No.
Yeah.